Welcome to this lesson. In this lesson, we are going to be discussing about area. I'm teacher Agnes. Now, when we talk about area, this refers to the extent of the surface occupied by matter. If you look at this book, we have the cover of this book. So the whole of this surface represents the area of this side of the book. If you look at this side, the whole of this represents the area of this side. So like you can see, this area is bigger than this area. Now area is measured using the main unit of the SI unit for area is square meters, and square meters is denoted as m squared. Now other common units of area are centimeters squared, millimeters squared, then we have R, and then we have hectares. So how do these units relate? So you're going to start with meter squared as compared to centimeter squared. So 1 meter squared is equal to 10,000 centimeters squared. Then meter squared and millimeter squared, 1 meter squared is equal to 1 million millimeter squared. Then between meter squared and R is bigger, so 1 R is equal to 100 meters squared. Then 1 hectare is also bigger than a meter squared, so 1 hectare is equal to 10,000 meters squared. So you can always use these relationships to convert between any two units of area. So we're going to do some conversions here. We're going to convert, so convert 40 hectares is denoted by HA to meters squared. So for us to convert, we just have to use this relationship that 1 hectare is equal to 10,000 meters squared. What about 40 hectares? So this will mean that we multiply 40 by 10,000, which is equal to 400,000 meters squared. Let us try and convert, okay? So here we're going to convert 200 meters squared to us. So what is the relationship between R and meter squared? So 1 meter squared, or 1 R is equal to 100 meters squared. So now we have 200 meters squared. So in this case, you realize that you will cross multiply 200 times 1 divided by 100. So 200 divided by 100 will be equal to 2 R's. So 200 R's will be equal to 200 meters squared will be equal to 2 R's. Alright, let's look at the final conversion. We're going to try and convert 50,000 centimeter squared to meter squared. Convert 50,000 centimeter squared to meters squared. So the relationship between the two is this, that 1 meter squared is equal to 10,000 centimeters squared. So what about 50,000 centimeters squared? So if you cross multiply, you realize that you're going to have a division. 1 times 50,000 divided by 10,000. So what is 50,000 divided by 10,000? That will be equal to 5 meters squared. So make sure that you note down these relationships between any two of these units of area, so that when you need to convert, you can always use this as a guideline. Now we are going to look at how do we determine the area of a plane figure. So now learners, we are going to discuss how to determine the area of different figures. So here we are going to have the figures. Okay, the first one that you're going to look at is a triangle, and a triangle has three sides. So this is the base, this is the height, and this angle is 90. You can also have another triangle that looks like this. Okay, where this is 90, so this is the height, and then this is the base. So when it comes to a triangle, what is the formula for calculating the area of a triangle? So the area of a triangle is given by a half times base times height. So a half times base times height. If you are dealing with this type of a triangle, the whole of this length is a base. So a half times base times height. So next, we are going to move on to a square. So a square has four sides, and all the sides are equal. Okay, so this is side and this is side. So how do we determine the area of a square? So for a square, the area is equal to side times side. Alright, side times side. Next, we have a rectangle. So what is the difference between a square and a rectangle? So for a rectangle, all the sides are not equal, but the opposite sides are equal. So this is our rectangle here. So that you can see the sides are not equal, but this side is equal to this one. We call that the length. Then this side is equal to this one. We call that the width. So the area, okay, the area of a rectangle is given by length times width. Length times width. Here, side times side. Then the next figure that we are going to look at is a trapezium. Alright? So figure number 4 is a trapezium. Now a trapezium can assume two shapes. So we have trapezia that look like that, and then another one that looks like that. So one of the two opposite sides is A, and then the other one is B. So A and then B. Then since the angle here is 90, this is H, which is the height of the trapezium. And then in such a trapezium, we create our own height. Alright? So the area for a trapezium is given by a half into A plus B, then we multiply by height. A half A plus B, then we multiply by height. Then we have a rhombus. Okay, so we have a rhombus. So for a rhombus, it's like a slanted square. Okay, so in this case, we have this as the baseline. We can call it L. Then here we have the height of the rhombus. Alright? The same case happens for a parallelogram. So how do we determine the area of a rhombus? So area is equal to baseline times the height. So this is the same case with a parallelogram. So it's like a slanted rectangle, but it also has a baseline and then it has a height. So the area is given by the baseline times the height. Then finally, we have a circle. So we have a circle. So a circle always has a radius from the center of the circle to the circumference we have r. So how do we determine the area of a circle? So the area of a circle is equal to pi r squared. So it is important that you remember these formulas because based on the figure that will be presented to you, you will be required to determine the area. So for a triangle, the area is given by a half base times height. For a square, side times side. For a rectangle, length times width. For a trapezium, a half into brackets a plus b times the height. For a rhombus, base times height. Parallelogram, length times height. And then for a circle, pi r squared. So now we're going to do some questions on this. So now we're going to practice the formulas that we have learned using these questions. Calculate the area of the shapes below. The first one is a triangle. So we have said that the area of a triangle is equal to a half base times height. So this is a half times the base, which is 4, times the height, which is 5. By 2, 1, by 2, 2, 2 times 5 is equal to 10. Do not forget the units of area. If you are dealing with centimeters, this is centimeters times centimeters, which is equal to centimeters squared. Then, number 2, we have a rectangle. The area of a rectangle is given by length times width. So length is 8 centimeters. The width is 6. So when you multiply 8 by 6, you get 48 centimeters squared. Do not forget the units. Then we have a trapezium. The area of a trapezium is equal to a half into brackets a plus b, then times the height. Remember, a and b are the two parallel sides. So here we have 7 plus 10. Then we multiply by the height, which is 4. So area will be equal to a half times 7 plus 10 is 17 times 4. By 2, 1, by 2, 2, 17 times 2 is equal to 34 centimeters squared. Moving on now, here we have a parallelogram and we need to determine the area. So we said that the area of a parallelogram is given by the base length times the height. So the length is 8 centimeters and the height is 5. When you multiply, you get 40 centimeters squared. Then finally, here we have a circle, and the area of a circle is given by pi r squared. So pi is 22 over 7. The radius is 7 times another 7 because we want r squared. So by 7, 1, by 7, 1. So now we have 22 times 7, which is equal to 154 centimeters squared. Now sometimes you can combine two figures to form a compound figure. Alright? You can combine two rectangles. You can combine, a rectangle and a triangle. How do you approach those type of questions? So now we are going to look at how to determine the area of compound figures. Now we are going to work with these two figures and we are going to determine the area of the shaded regions. So in this case, we have two rectangles. One is small and the other one is big. So the space between them is shaded and we need to determine that area. So when you look at this, you realize that if you take the area of the big rectangle minus the area of the smaller rectangle, you will be left with the area of the shaded region. So all we have to do is to determine the area of the big rectangle, which is 7 centimeters by 6 centimeters, which is equal to 42 centimeters squared. Then the area of the small rectangle will be 4 centimeters by 5 centimeters. So 4 centimeters by 5 centimeters, which is equal to 20 centimeters squared. So now the difference between the areas of the two is the one that will give us the area of the shaded region. So our area will be equal to 42 minus 20, which is equal to 22 centimeters squared. Now in the next figure, like you can see, we have a circle. Then inside the circle, we have a triangle. Now the triangle is a right angled triangle because its angle is 90. The base of the triangle is 14. And if this is also the radius, then it means that this is also 14 centimeters. So the shaded area, if you look at the shaded area, it is outside the triangle but inside the circle. So we are going to determine the area of the circle. Then we subtract the area of the triangle and we will be left with the area of the shaded region. The area of the circle will be given by pi r squared. So this is equal to 22 over 7 times the radius, which is 14, times the radius again. So by 7 1 by 7 2. So now 22 times 2 is 44. Then times 14, we get 308 centimeters squared. So next, we are going to determine the area of the triangle. So area of the triangle will be equal to a half times base times height. So this is a half times 14 times 14. So by 2 1 by 2 7. So now we have 14 multiplied by 7, which is equal to 98 centimeters squared. So remember we have said, if we take the area of the whole circle, we subtract the area of the triangle, then you'll be left with the area of the shaded region. So area of the shaded region will be equal to 308 minus 98. So this will be equal to 210 centimeters squared. So the area of the shaded region is equal to 210 centimeters squared. So anytime you come across two figures that have been combined and then you are required to get the area of anything from the two, just think broadly and see what you can either add or subtract to get the required area. So we have looked at how to determine the area of regularly shaped figures. What if you have an irregularly shaped figure? How would you determine its area? Now, area of irregular plane shapes can be determined by tracing them on a grid that has squares of 1 centimeter squared. So the area of each square here is 1 centimeter squared. So here we have our pink shape on our white grid. So what we do, you realize that the shape is covering some squares. Some squares are complete and others are incomplete. So the area of an irregularly shaped object is given by counting the complete squares. Okay, so we take the complete squares, then we add to the incomplete squares divided by 2. Divided by 2. So we are going to begin by counting the complete squares. So the complete squares here are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All the others are incomplete. So here we record as 15 plus. So the incomplete squares, we are going to count them. So starting at the top, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So here we have 25 and then we divide it by 2. So this will be equal to 15 plus 25 by 2 is 12.5. So this will be equal to 27.5 centimeter squared. So it's centimeter squared because each one of the complete squares was 1 centimeter squared. So the area of this figure can be said to be equal to 27.5 squared. Now lastly, we are going to look at if you combine two plane figures, like if you use squares to make a cube, how do you determine the area of that cube? So how do you determine the area of solids? So now learners, we are going to look at the surface area of solids, and we are going to focus on 3 solids. We're going to focus on a cube, a cuboid, and then a cylinder. So when we talk about solids, we are talking about a book like this. This book is a solid in the shape of a cuboid. So you realize that we have how many faces? 1, 2, 3, 4, 5, 6. Each face has an area. So the faces of a cuboid are made up of rectangles. So this is the length of this rectangle times the width, length times the width, then length times the width. So when we talk about a cuboid, we have 6 faces. So for us to get the surface area of the cuboid, then we have to account the area of the 6 faces if the cuboid is closed. So this being a cuboid, this is a closed cuboid. So like you can see here, we have a length here and a width. Then here we have another length and its width. Then here we have this length and its width, and so on. So what you do, you just have to ensure if this is a solid such that all the sides are closed, then you need to get the area of this face plus the area of the other face, the area of this face plus the area of the other face, then the area of the top face plus the area of the face at the bottom. So there's no specific formula to use, you just have to ensure that you get the area of the 6 faces. Then when it comes to a cube, so a cube is made of squares. So in a cube, all the sides are equal. Okay? All the sides are equal. So we have 6 sides also. So if this is side and side, the area of this will be side times side. Then how many sides are they? They are 6 sides that are equal. So the surface area of a cuboid can be said to be equal to 6s squared. However, you don't need to cram this formula because for a cuboid, for a cube, you just need to make sure that you take account of the area of each and every face. Then finally we have a cylinder. Okay, so this is it. So For a cylinder, we have three sides. We have a circle here, and then we have another one here, and then we have the curved surface. So for us to get the surface area of a cylinder, we will take into account the area of the two circles which are equal. So pi r squared is the area of one circle. So since they are 2, we multiply by 2. Then we add to the area of the curved surface, and the area of the curved surface of a cylinder is given by pi dh. Okay, pi dh gives you the area of the curved surface. So surface area of a cuboid which is closed on both sides is given by 2 pi r squared plus pi dh. Now if it is open on one side, so this is closed on both sides. So if it is open on one side, open on one side. So that means that we'll only have one circle. So the surface area is going to be equal to pi r squared plus the curved surface, which is pi dh. Alright? And then if it is open on both sides, okay, open on both sides means that only the curved surface is present. So the surface area is going to be equal to pi dh. So it is very important to note that anytime you are calculating the surface area, it has to be the area of the sides that you can touch. If the cuboid is open on one side, then you can't account for the area of the open side. Okay? Same case to a cuboid and same case to a cylinder. So now we are going to look at some questions that we can do to determine the area of these solids. Learners, we are going to calculate the surface area of these solids. The first one is a cuboid. So we are going to ensure that we take account of the area of every side. So we are going to begin with this side, which measures 10 by 5. So there are two of these sides, there's one on the other side. So our area 1 is going to be equal to 10 times 5 times 2, which is equal to 100 centimeter squared. Now area 2 will be equal to, we are going to take account of this side, which measures 8 by 5 centimeters, 8 by 5 centimeters, and because we have one on this side, we multiply by 2, and this will be equal to 80 centimeters squared. Then area 3 will be equal to the area of this face plus the one at the bottom. So this measures 10 centimeters by 8. So 10 times 8, then we have two of those, which is equal to 160 centimeters squared. So the total surface area will be equal to the sum of these three areas. So remember, each one of these represents two sides. So this is the area of the 6 sides. So 100 plus 80 plus 160, that would be equal to 340 centimeters squared. Then now the next shape is a cube. Like you can see, for a cube, all the sides are equal. So we have 6 faces. So surface area will be equal to, the area of one face is 4 times 4. But we have 6 faces that have the same dimensions. So we multiply by 6. So this is 24 multiplied by 4, which is equal to 96 centimeters squared. 4 times 4 is 16. 16 times 6 is 96 centimeters squared. Then finally, we have a cylinder, and we have 2 circles, alright? One at the top and one at the bottom. So we are first going to get the area of the circles, which is equal to 2 pi r squared. This will be equal to 2 times 22 over 7 times 7 times 7. So by 7, 1, by 7, 1. So this is 2 times 22 is 44. Then 44 times 7. This will be equal to 28. 8 carry 2. 4 times 7, 28 plus 2, 30. So this is equal to 308 centimeters squared. Next, we are going to determine the area of the curved surface. So we call that area 2. The area of the curved surface is given by pi dh. So pi is 22 over 7 multiplied by the diameter. Now since the radius is 14, the diameter is going to be equal to 28. Then we multiply by the height, which is 20. So by 7, 1, by 7, 4. So here we have 22 times 4, which is 88. Then 88 times 20 will be equal to 1,760 centimeter squared. Now that we have the area of the grid faces in a cylinder, we can get the total surface area, which is going to be equal to 308 plus 1,760, and this will be equal to 8 plus 0 is 8, 0 plus 6 is 6, 3 plus 7 is 10, so 0 carry 1 plus 1, 2. So 2,068 centimeter squared. So I want to believe that you have now learned everything that you need to know at this stage about area. So now I'll give you questions that you will use to practice what we have learned in this lesson. Learners, attempt these questions. Number 1, convert 0.05 hectares to meters squared. Number 2, determine the area of a circle whose radius is 10 centimeters squared. In this case, use pi to be equal to 3.142. Then, calculate the surface area of the cylinder below whose top is open. So the top part is open, only the bottom part is closed, of course, plus the curved surface. So the radius of this is 21 centimeters and the height is 50 centimeters. Thank you so much for being here with me to learn about area. See you in the next lesson.